MAP-21 performance measures. My name is Cindy Vong, and I'm the marketing coordinator here at Iteris. Before we get started, I'd just like to let you all know that we are recording this webinar and will make this webinar available on Iteris' website for future viewing at www.iteris.com. In a few moments, I'll be handing this webinar over to Rob Rannick, Vice President at Iteris, who will be going over the Iteris Performance Measurement System, also known as IPEMS. In particular, Rob will be talking about how agencies such as yourselves can leverage big data for performance measures using IPEMS. Should you have any questions during this presentation, please feel free to type your question into the chat box and we'll do our best to answer your questions at the end of the presentation. With that, I think we're all ready for you, Rob.
Thanks, Cindy. So I'm really happy to be able to kick off our MAP-21 Performance Measure webinar series today. We're going to have a series of webinars focused on the practical issues that agencies are facing to implement MAP-21. And today is the first one of that webinar series. What we're going to talk about today is just a brief overview of Iteris and the iPerform division within Iteris. We're going to talk about some of the specifics of performance measures in MAP-21 in terms of the rulemaking schedule, as well as the specific measures that we see coming down the pike for agencies to actually implement. And then in terms of implementation, we're going to talk about some of the methods from a quantitative perspective that agencies can use to implement these measures, and then some of the data that is available to agencies for implementation. And then we're going to wrap it up with a demonstration of our flagship performance measurement product called Iteris PEMS. But before we get to that, I just want to give people a sense of who Iteris is and who the iPerform division is. Iteris is a publicly traded company that is a leader in the intelligent transportation systems traffic management space. We've been a public company since the 90s, based in Orange County, and we have three primary divisions. We have a sensors division that sells video analytics and other sensor products to agencies. We have a systems division that builds large-scale, complex ITS systems for transportation agencies. And we have the iPerform division, which is really focused on data and analytics for public sector transportation agencies. And the way that we often talk about what we do within iPerform is encapsulated in this image here, sort of an iceberg. And the way that we think about assisting agencies in implementing performance measures is that there are really three elements to how you implement performance measures. You have kind of the tip of the iceberg, which is the measures themselves. That's kind of what's above water agencies, what's visible in terms of what's actually getting reported. Then surrounding all that, the water, is the data that agencies have available. And really the good news is that the data that's out there is really increasing every day in terms of what agencies can use and what agencies can leverage in a cost-effective way to generate performance measures. And within the iPerform division, what we really focus on is bridging the gap between that data and final performance measures using analytics. And so what we offer are a variety of services and products around analytics to help agencies suck in all of this data and turn it into the performance measures, not just that will be required by MAP-21, but that agencies can use to integrate into their daily business processes and decision making. And that's really our goal for public agencies at iPerform, is to help leverage this data to effectively measure the performance of their systems. And we offer services to help agencies do that. We also have products. Our core product, a lot of people I know are familiar with, is the IPEMS system. This is the Iteris Performance Measurement System. What you're seeing now is a screenshot of the latest version of IPEMS that's actually taking in probe data and translating it into actionable measures on this dashboard for public agencies. And I'll be doing some demonstrations of the IPEMS system in a little bit, some live demos with some live data. But before I get to that, I'd like to talk a little bit about MAP-21 from our perspective and talk about some of the advice that we've been giving clients in terms of MAP-21 preparations and compliance. So for those of you who've delved into MAP-21 a little bit, this is probably a familiar diagram. This is the schedule, the proposed schedule for the three areas of performance measurement implementation in MAP-21. There's three main tracks. On the left, you have the safety track. In the middle, you have the pavement and bridge asset management track. And on the right, you have what they call other performance measurement areas, which are really basically system operations types of performance measures. And you can see that really this year, 2013, has been a consultation year where USDOT has taken in a lot of input from various stakeholders and pulled that together in advance for the next step, which is their notice of proposed rulemaking. One thing to note is that for this third area, for the system performance measures, which is what I'm going to focus on today, that originally the notice of proposed rulemaking, you can see according to this schedule, was expected out early next year, essentially next month sometime. Our best intel tells us that that's probably going to happen later, sometime around May. So if you've been looking for that notice of proposed rulemaking, you essentially get an extra 5 months or so, based on our best intel, to prepare for that coming out. And then after that comes out, of course, there'll be a comment period, then followed by final rulemaking. And then the implementation dates are essentially not shifting. And for the system performance measures, that's going to be phased in basically starting in calendar year 2050. And so that's the roadmap in terms of schedule for the system performance measures under MAP-21. If you think about it, the roadmap in terms of measures, I think that we already have a fairly good idea of what the basic measures are going to be for system performance. And we know this because there's been a pretty widespread consensus, I would say largely assisted by the AASHTO Committee on Standing Committee on Performance Measurement, and particularly a white paper that they put out at the end of 2012, so about a year ago, that talks about the types of measures that they recommend under MAP-21. We think that even though it's not obviously a rule yet, these two core measures that AASHTO recommended, delay and reliability, are going to be the key measures in MAP-21. Anyone who's really interested in this topic, I highly recommend the AASHTO white paper from last year. I'll have my contact information at the end, so if anyone is interested in getting a copy of that, you can ask us and we'd be happy to send it out. In terms of the basic measures, it really looks like it's going to boil down to reporting on delay in terms of annual vehicle hours, as well as CMAQ-based reductions in delay, and then some sort of travel time reliability index, probably the 80th percentile. Previously, agencies had focused on kind of higher percentiles like 95th, but it looks like 80th is the target for MAP-21. The modes that these types of measures are going to need to be reported for are really vehicles on the national highway system and freight vehicles as well, separately. And these types of agencies that this is going to apply to are state departments of transportation and metropolitan planning organizations. And so if you're a state DOT or an MPO, these are the types of measures that you should start thinking about. How are you going to report these under MAP-21? We can go a little bit further in terms of looking at the measures themselves, and as anyone who has worked on performance measurement before knows, the devil is really in the details. And so we know a little bit, we know some things about what are the details of these measures, but we don't know everything. in terms of the things that we do know now, we know that delay is going to be reported in vehicle hours. And that is something that is important to note because it has big data implications that we'll talk about a little bit later. And reliability is going to be some percentile. The key items for both of these are what are the thresholds for reporting delay and reliability. You can report delay using various speed thresholds under which delay is recorded. And for reliability, you can pick essentially any percentile about which you want to report travel times. But it looks like the delay thresholds are a little bit more up in the air, but the reliability looks like it's going to be at the low end of this range, 80th percentile most likely. It looks like these measures are going to be reported both for segments or routes, however you want to define them, and regions as well, and that the spatial scope, the types of facilities that you're going to need to report these on, are essentially interstates and the national highway system. In terms of what is less known is really about the time dimensions of this and the targets. And so you can report these in lots of different ways. For example, you could report every hour, what is the delay between 8 a.m. and 9 a.m. on weekdays. You could report for a peak period. It looks like leaning towards a peak period. And then the scope in terms of how large of a time period you need to collect the data for this is still a little unknown, maybe left loose in the rulemaking. That's our current guess. And then the key item for a lot of agencies that we really encourage people to think about now is what are the targets that we want to hit for these measures, because our best intelligence is telling us that this is something that's going to be left to the states and the MPOs to set for themselves. And so the earlier the agencies start to think about what are the targets we want to set, the better from our perspective. I'm now going to talk about some of the methods for calculating these measures. And the methods can get complex. And so what I'm going to do is I'm going to use an example and talk about the methodology for computing both delay and travel time reliability on this example. And so the example I'm going to use is a trip going from our offices up here in Berkeley in the San Francisco Bay Area down to Silicon Valley. So this trip goes through San Francisco over a bridge and then comes down through Palo Alto down to Silicon Valley. And so the way that you would calculate delay conceptually along this route can be shown in this diagram here. So the horizontal axis is the distance down the route. On the left-hand side is the beginning of the route. On the far right-hand side is the end of the route. And on the vertical axis is the speed. And then if you imagine yourself as a vehicle driving down this route and hitting congestion, this is what that would look like. You would start out going relatively quickly. You would hit a queue and start to slow down. You would kind of crawl along through congestion, a very typical experience here in the Bay Area. And then once you got up to the cause of the bottleneck, you would essentially return to free flow speed. And when you have delay, you have a threshold speed under which delay is recorded. And in this case, the threshold speed would show you that during this time period, where you're traveling between these 2 points, this vehicle is under delay. So this vehicle would have experienced vehicle hours of delay during that time period. You can calculate this a lot of ways. One way is you can calculate it for every vehicle. That's not typically a realistic way. Sometimes you can get samples of delay from vehicles and use that to roll up. I'm just going to show one method here, which is estimating it from spot speed data. And so this could be data either gathered from a probe aggregator, such as here, or INRIX, or it could be pulled from spot detection, such as loop detectors or radar systems. And so if you have spot detection along the system, the spot detectors will show different speeds along this route, the red ones being slow, the green ones being fast here. And the way that you would calculate delay is you would actually look at the midpoints between each of these points where you have speeds and assume essentially a steady speed between those points and then calculate delay from that. And so the delay here you'll notice the boundaries don't exactly match, but they're approximately to what we would experience if we drove it. And so that's one example of how we would compute delay from a certain type of data. Now I'm going to talk about computing reliability. One of the big challenges we've found, particularly in the work that we've done with national academies under the SHARP program on reliability monitoring, is just an engineering challenge of going from deterministic precise points, which is the travel time, to a probabilistic concept of what a travel time is. And so in this case, the deterministic point is this little box over here that represents the travel time. And in terms of reliability, the way that we like to think about it and explain it to agencies is that reliability is really a probability density function of all possible travel times between two given points. And so that's represented over on the right by this little curve. And so the curve is showing you what are all the possible travel times if I left at a certain time. On the left are the lower travel times, on the right are the higher travel times. And you can actually model this once you collect enough data. And then the way that the 80th percentile is calculated from this is very simple. You just look at the 20th percentile highest travel times and just draw a line there. And you say that's the 80th percentile for travel time reliability. So once you build this probabilistic model, it's actually quite simple to calculate the 80th percentile. We recommend that clients think about it from more of this probability density function, because then you can calculate whatever percentile that you want, regardless of what you need to report. One of the ways that we've visualized this for clients is this little animation here, which is showing the boxes, again, as travel times for this particular route. This is actually real data for this route. And showing if you left at 8 a.m. on all these different days, this is about 3 months of days, what are the different travel times that you would experience leaving at 8 a.m. on this route? And on the left are the lower travel times, and on the right are the higher travel times. So you can see this is kind of weighted towards a lot of higher travel times because 8 a.m. is the peak commute period here in the San Francisco Bay Area. But what you can do once you gather this is turn this into a red line that shows what is the actual probability density function for all of these different travel times. And then you can actually look at that within the context of a full day. So here we're just showing 8 a.m. So this little red slice out of the circle up on top is just showing the exact same data as we're showing down here, the travel times at 8 a.m. But you can actually gather this from either probe data or sensor data. You can gather it for, say, every 5 minutes and look at it by time of day. And so that's what we've done here. So for 3 months of data, we've looked at this particular route by time of day. And you can see here in the circle plot where the higher travel times occur on kind of the outer edge and the shorter travel times occur more toward the center. You can actually see the different travel times by peak period flattening out, thus getting less reliable, and pushing out to the edge, thus getting longer. And then during the off-peaks, you can see them get more peaked and more close to the middle. That means getting shorter and getting more reliable. And so this is ultimately kind of the back end of what a travel time reliability calculation and monitoring system is doing is it's taking in all this data for different time periods and building this type of model for particular routes. And then once you do this, you can calculate 80th percentile or whatever percentile travel times for essentially any time frame within the day. But on the back end, this is kind of what this looks like conceptually in terms of travel time reliability. So we've talked a little bit about the schedule, the roadmap, and we've talked about the measures as well and some of the methods for calculating them. Before I go to some of the demos of IPEMS, I'd like to just talk briefly about the data systems for taking in this data. What are the types of data that you're going to need to report on MAP-21? And the way that we at Iteris think about sensor technologies is we sort of categorize them into 3 main technology families. One is infrastructure detectors, then hybrid detectors, and then mobile detectors, all represented on this little picture right here. And the infrastructure detectors are anything that's attached to the infrastructure. These are things like radar, video, loop detectors, anything that physically lives attached to a piece of infrastructure. And these can calculate typically anything from the number of vehicles that went over them to the speeds of the vehicles. That's an infrastructure detector. On the other end of that spectrum, you have these mobile detectors. These are essentially any mobile device with a GPS chip and a cellular data connection. That's what we consider a mobile detector. What these send out are locations and speeds, essentially. And of course, as many people know, these are now being aggregated by third parties like HERE, like TomTom, like Iteris, that are taking this in for individual vehicles and then turning them into average speeds over, say, a given minute on a given segment of the roadway network. And in between these types of sensor technologies, there's actually a third type that we often use for clients, and that is what we call hybrid detectors. So in this case, part of the sensor actually lives in the vehicle, like on the mobile sensor, and part of the sensor lives on the infrastructure. And a good example of that is a Bluetooth type of system, like the Velocity product that Iteris sells. And what Bluetooth devices do, for those who aren't familiar, are they essentially ping your cell phone as it drives by and get an ID from your cell phone. And then another device further down the road pings your cell phone again, gets the same ID from you, and then matches it to come up with the travel time. And so the way that we think about data for performance measurement and the way that we advise agencies is really in the framework of these three types of sensor technologies. And as it turns out, you can use lots of different what we call data profiles to calculate the types of performance measures that we believe are going to be in MAP-21. This table here gives you an example of the different types of profiles that we're talking about, all the way from, for example, on the left, what we call a more traditional profile, which is a lot of detection stations, infrastructure detectors. These are things like loops and radar. If you just have that and you have a very large coverage, you can essentially calculate delay and travel time reliability. All the way over on the right to a mix of that, as well as probe data and these hybrid re-identification types of sensors. The bottom line is really shown on the top two bullets here, which is that when it comes down to it, for the types of measures that we're talking about under MAP-21, you really need both speeds and travel times. That's essentially the same measure if you're looking at a small enough segment, and volumes. So you need some version of speeds and travel times and volumes. And we think a lot of the art of implementing MAP-21 will be coming up with what's the right mix of those two types of data. And then the profiles below show all the different deployment scenarios that can generate that data to then calculate the MAP-21 performance measures. One of the questions we get asked a lot about since the fall is the National Travel Time data set. For those of you who are not familiar, this is a data set that US DOT purchased from HERE and is now offering for free to public transportation agencies on a monthly basis, kind of historical archive data on a monthly basis. And it gives travel times for various segments on the network. This is a type of data set that we've been working with a lot here at Iteris, especially over the last year. We have just a group of data scientists that work with this type of probe data and figure out how to build performance measures on top of it. This is showing an example of the coverage of that data for the Bay Area. On the left, you can see a map of the Bay Area, and on the right, you can see the locations of the data, the probe data for this. I'm not going to go into depth on this particular travel time data set for this webinar, but the next webinar in the series, which will happen sometime in January, we'll dedicate to this topic of how do you use this National Travel Time data set, this free data set, to comply with MAP-21, and essentially how far can it take you as an agency toward MAP-21 compliance, which is the most common question that we get now from agencies. So with that, I'm going to go through a couple of demos, IPEMS demos, and talk about how you can use IPEMS to comply with a lot of the MAP-21 requirements that we've been talking about here. And then in about 5 or 10 minutes, we'll open it up to people's questions. So in terms of the performance measurement system, for those of you not familiar, this is a live version of the system that's running in California. This system here, the screen here is showing in real time what's happening statewide in California. Here you can see it's calculating travel time reliability for the AM and PM peak periods for today. And here you can see it's calculating delay by day of the week. And it's showing in red here what's happening this week, and then in blue and green what's happened last week versus last year. So you can see today we're having more delay, or yesterday, I'm sorry, we're having more delay in California than we typically have. And so you can see that delay and travel time reliability are really core to the measures in the PEMS system. The way that PEMS computes this is it takes all of this data up in real time and displays it on a map. Here you can see the real-time data in California right now, what's happening right now in California, including things like incidents. This is a little incident here. The key to the IPEMS system, however, is that it doesn't just take the real-time data, that is what's happening right now, like we just looked at, but it actually saves every piece of data that you send it. So if you step backward in time here, you can see the data stepping backward in time as well. So now it's 7:55 this morning, kind of the start of the AM peak commute. And so that's really the key to IPEMS, is that it never throws away any data regardless of the source, and instead it uses that data to run analytics and calculate performance measures. One of the fun things you can do with that is you can visualize data in interesting ways. This is showing, for example, what's happened yesterday on the stretch of the 405 in Los Angeles, and you can see both the map of the freeway here and an animation of congestion. So right now it's like 4:30 yesterday in Los Angeles, and you can see the circles here are programmatically identified bottlenecks. These little blue diamonds are incidents. And then over here you can see a lane-by-lane freeway schematic of the congestion, including the HOV lanes. You can see the congestion building up over time, and you can drag this slider at any point in time. Now this is 5:30, or we can go to 5, and visualize exactly what's happening on the system. So PEMS is really a broader performance measure and analytics system that can do a lot with the data that you have as an agency. But because we're talking about MAP-21 today, I'm going to focus a little bit on just some of the basics of how the IPEMS system reports things like delay. So here you can see for the state of California, right up to through yesterday, for the last 2 weeks, what was the overall delay at a speed threshold of 35 miles an hour. And you can see here that the IPEMS system lets you choose lots of different thresholds for delay. And then it's reporting by district in California. These are Caltrans districts. The amount of vehicle hours of delay for different districts. You can see summing up to nearly 10 million vehicle hours of delay for California. So this gives you a sense of how the system pulls up the delay from very small data sources up to a high level. You can actually also drill down into delay at more of a micro level. So you can click on any section of the roadway here. I've clicked on a section of the roadway in the East Bay area near San Francisco, and you can see in real time the speed here in blue, and then the expected speed range here in gray, the average here in dark gray. And then if you click into this, you can actually look at the delay on this particular section. This is looking at the last week delay, essentially up to right now, and you can look at vehicle hours of delay at this 35-mile-an-hour threshold, 4 different lanes, and then total as well. And so this should give you a good sense of how you can kind of drill down into the system and look at delay. You can do the same thing with travel time reliability. So for every route inside of the IPEM system, like the one that we're showing here, you can calculate reliability. And I should step back and say for each of these routes, you can define them however you want. So in this particular case, the route starts at 405, then goes to the 22, then goes to the 55, then the 91, the 57. So routes can span many different signed routes on the system. And in this case, it's calculating the median, the 20th percentile, and the 80th percentile of travel time reliability for the last 2 weeks. And so you can see this is the 20th percentile, this is in green the median, and in blue the 80th percentile travel time for the last couple of weeks here. And so you can do this with any route, and you can change these numbers to any number. And the reason that you can change this and show any number is that we build up in the IPEM system this background little 3-dimensional model that I was showing earlier. So you can show any types of statistics that you want to on travel time reliability for routes. One of the exciting new features that we built into the IPEM system this year is to pull in this vehicle probe data, third-party data from here, NREX, or any provider in real time, and save it in the system just like any other piece of data. And so here you're looking at a live version of that. Actually, this is, I think I dragged it back to a couple hours ago. So here's a live version of what's happening in Los Angeles right now. And this is pulled actually from the HERE data set right now in real time, but this can be changed to whatever probe data set that an agency has purchased. And with this data set, one of the things that you can do is you can draw arbitrary routes, just like the one I was showing before, and you can calculate speeds. Here you can see the speed on this route here dipped well below the average, almost down to 30 miles per hour this morning at about 9 a.m. Normally it's about 55 miles an hour, something like that. And so you can do this in real time, just create a route and show this, and then you can calculate travel times on this as well. So this is an exciting new feature of the IPEM system in terms of taking in new data that we're going to be demoing at TRB this year in January. So for anyone who's coming to TRB, please stop by the Iteris booth, and we'd be happy to give you a demonstration of the new version of the IPEM system that takes in the third-party data. And we're also going to be demoing some of that travel time data set as well, and some of our insights into that. But look for a new webinar for those of you especially who can't attend TRB. Look for our next version of this MAP-21 webinar series in January on that national travel time data set. And of course, in general, please feel free, always free to get in contact with me. This is my contact information here. More than welcome to email me or call me anytime if you have any questions about MAP-21. And with that, I'll turn it back over to Cindy for any questions you have right now.
Thanks, Rob. So it looks like the first question we have is, can we meet MAP-21 requirements with third-party data such as NREX or HERE?
Yeah, that's a good question. The short answer is probably not just with that data the way that things stand right now. And the reason for that is that you need to find some way to report delay, and delay requires some count, some volume number of the number of vehicles that are experiencing delay. And that third-party data from folks like HERE is great at reporting speeds or travel times, but you don't get a lot of insight into the number of vehicles that are passing a certain point. And so it may be that you can comply using kind of broad brush measures of number of vehicles like AADT, average annual daily traffic, but it's probably more likely that you're going to need something a little more detailed than that for MAP-21. At least that's our current advice to clients on that. And so we think that is a great set of data to use, but probably not the sole source of data that you need for MAP-21 compliance.
Okay, so another question is, when should I begin to implement MAP-21 requirements?
You know, especially with the delay in the rulemaking to May, we think that really now is the time to start experimenting with this. We've seen states do this. Places like New Jersey have done some experiments on implementing measures. And our general advice to clients is, if you want to get in the game and really have feedback in the rulemaking process, the best thing to do is to try to implement some measures at a pilot level as soon as possible and start understanding what are the complexities with doing that, so that you can give good advice back to USDOT in terms of the implementation of these types of measures. So the sooner the better is our main advice on that.
Okay. What discussions are occurring to go beyond the reporting and diagnose causes and strategies for alleviating congestion?
You know, that's a great question. That's really ultimately our vision for clients, is how do you do more than just report on measures, but how do you actually start to diagnose what the issues are? And I'll just put back on one of the screens here. You can see that these types of visualizations that we showed are one of our answers to that. And so if you have this type of data, like let's actually go stretch this a little longer. So you can actually see here visually when congestion starts. This is a very tough section of the 405 from a traffic perspective. You can see when congestion starts here. It starts maybe around 3-ish, something like that. And then you can watch it develop, and you can watch it then clear around 7:45 or something like that. And you can actually see in between incidents as they occur. And so like I said, this is for yesterday. You can actually go to this calendar and choose any day that you want to look at, including averages, and start to really build up a sense of what are the operational issues that are causing congestion on this corridor, where exactly are my bottlenecks, things like that. As another example of that, these little circles here, which you can take off or on, these are programmatically, automatically identified bottlenecks on the system that the IPEM system is identifying here. And so there are other screens in the IPEM system that let you actually go look at where all of these bottlenecks are occurring on your system. And so if you looked at the little circle that we just highlighted there, you can actually go say, okay, for this circle, now I want to see regionally where all the bottlenecks are occurring, and you can put them on a map. These are showing for the Bay Area, for example, all of the bottlenecks that occurred in January of this year. And if you want, you can do things like say, I only want to focus on the really large bottlenecks. These are bottlenecks that were 6 miles in length or longer. Or you can say, I only want to focus on the really recurrent bottlenecks. These dark red ones recurred almost every day during January. Or you can say the opposite. For example, I only want to focus on the non-recurrent bottlenecks, which are shown here, and figure out how to deal with that. And so there's a lot of tools that we've built into the system and built into our services practices that help agencies identify the causes of congestion and hopefully help solve them. That's our ultimate goal, is to go well beyond MAP-21. So that's a great question. I've sort of focused here on the MAP-21 piece of it because that's such an important topic for our clients, but our ultimate goal is to develop tools that can help diagnose and help agencies understand how to fix congestion.
So Rob, typically how long before we implement a system like yours before we can start realizing its benefits and reporting for MAP-21 compliance?
Typically, for an IPEM installation, it takes on the order of a few months, sometimes as short as a month, depending on the types of data that an agency wants to hook up to the system. If you're just looking at data from someone like here, for example, that's the system we can really deploy in a matter of a couple of weeks. And then to start reporting on the types of measures that MAP-21 is going to require, we typically recommend a warm-up period of 1 to 2 months. And the reason for that recommendation is that for something like travel time reliability, as an example, there are more examples of this, but just one example, for travel time reliability, you really need to build up a historical pattern of travel times. That's not something that you can just take 1 day's worth of data on and then report. You typically need about a month's worth of data to report on that. So typically, for an agency, it'd be on the matter of a few months to have a system up and running and reporting on the types of measures that you need for MAP-21.
Is probe data from phone GPS incorporated in PEMS, and in general, is the data archived?
Yeah, that's a great question, and the answer is yes. What you're seeing here, what you're seeing on this screen is the HERE data for the LA region right now, and we can show pretty much any region of the U.S. And you can see the data, these speeds here are coming in real time. And so let me just turn off the incidents. These are actually real-time incidents from Waze that you see here from Google nowadays. But what you see here are the speeds, the different colors. And this is all from probe data, from cell phone GPS-based data. And it's HERE, the company HERE, formerly Nokia, takes this data and aggregates it up into segments, and then they have a live feed from their offices that we hook into, and that's what we're showing right now, is the real-time probe data from the LA region or whatever region you want to look at from HERE. And then in this system, what we're doing is we're saving this. So we get this every minute from HERE for every segment. And then depending on the type of contract that a client has with HERE, you can save all this data every minute and use it for internal analytics. And that's what this system is doing right now, is saving all this data essentially for all time to run analytics algorithms on for later.
Hey, Rob, can you go over what is the difference between PEMS and IPEMS?
That's a great question. So they are the same system. It's just that we've rebranded once we were acquired by Iteris to call the system IPEMS. And so for some of our oldest customers, like Caltrans, you'll see it's still called PEMS, but the system these days is just called IPEMS. And the I stands for Iteris, and the PEMS part still stands for Performance Measurement System. So there's just one system in terms of the IPEMS system. Great question.
How are the upcoming requirements from SafetyLoo on the real-time reporting of incidents on arterials by 2016 being considered by PEMS?
That's a great question, and that's something that we plan on covering in a little bit more detail. These are these former 1201 real-time requirements, for those familiar, that cover incidents and construction events in general. And we've put a lot of thought into this. This is really a data challenge more than anything else. There are definitely big analytics pieces as well. But one of the key things we've done, and I can illustrate it here, is we've partnered with Waze, which is now Google. And so the incidents that you see here are actually coming in from Waze. And so let's go click on one of them. So you can see that Waze is reporting 110 express lanes, hot lanes incident at this location right now. And for those of you who are unfamiliar, this is a really interesting and exciting source of crowdsourced incident data that is generated by users of a mobile application called Waze, now part of Google, so it includes actually Google Maps users. And so if you report on Waze, hey, I saw an incident, or there's a car stalled over here, or whatever, that actually gets pulled into Google's servers in real time from your mobile device. And then we have a feed between Iteris and Google that's pulling this data in real time. And that's what we're showing here on the map, is the real-time Waze data. You can see here on the right-hand side, this is a list of all the incidents that have been reported, starting with the most recent at the top in real time. And we marked what are CHP, in this case, Highway Patrol reported incidents. Oh, looks like we just got a couple more Highway Patrol incidents. Versus what are Waze reported incidents. These are crowdsourced incidents. And so to answer the question, that we view is going to be a great source of some of the 1201 or the former 1201 real-time reporting requirements data. And the Waze data is quite inexpensive now. If states or agencies are interested in playing around with it, we would really encourage you to get in touch with us. We are the exclusive provider of this Google Waze data, incident data, to public agencies. So we have an exclusive deal with them to pull this feed, essentially the real-time feed of all crowdsourced incidents from Waze, and that's what you're looking at here. And so that's one of the ways that we're working to meet those types of real-time reporting requirements.
Can you go over the dashboard view you showed and explain a bit more about what the dashboards are showing?
Yeah, that's a great question. So this is our latest and greatest dashboard. Again, if you're coming to TRB, I really encourage you to stop by our booth, and we can go through a deep dive on this. But the short version of this dashboard is that it's showing essentially what is happening in terms of congestion on your freeways and arterials. Here you can see that the HERE data covers both the freeway system and the arterial system. As we zoomed in, you can see it's covering the arterials as well. And then it puts in context, what is this saying at a regional level in terms of freeway congestion and arterial congestion compared to normal? And so you can see here we have these gauges that are showing, oh, freeway congestion is 14% greater than normal for this type of day right now. So it looks at essentially all of the previous Tuesdays for the last few months, or previous days that look like today. And then it says, okay, what do we expect? And we expected something more like this on the dark line here in terms of this freeway flow, free flow speed metric. And we got something more like where the gauge is here. And so this is about 14% above normal. And it's showing you what the range of normal is and what's happening right now for this. And in all cases, it's taking in this data and showing what's going on. It's also showing things like what percentage of your bottlenecks are recurrent in green here versus non-recurrent. And these are all algorithms on the back end of the IPEM system that are coming in and illustrating and calculating, what are the different types of metrics, including up here. We're showing the top bottleneck. So you can see the top bottleneck in I-5 and in LA in real time is the Interstate 5. It's a huge bottleneck right now in LA, and then I-10 is a little further down the list. But we encourage you, if you want a deep dive into more details on what the dashboard metrics are showing here, we encourage you to stop by our booth. We have little contextual help items above each one of them that hover, that pop up when you hover over them to give you some greater sense of that. But that's a great question. That's something we'd be happy to talk more about with agencies either offline or at TRP.
Can you capture sensor data from a pre-existing system and visualize it in your system?
Yeah, in fact, that's exactly what this system provides. So for example, let's go back to this visualization. Again, this is a live system. This is the Caltrans system. And these little circles here on the freeway schematic and the dots on the route. In fact, let me turn some things off so it's a little clearer. The dots along the route here are all of the different sensor stations. These are ITS stations along Interstate 405 in California. And these are a mix of stations, a lot of loops, I think, along this stretch, but there are also some radar, I think some little hockey puck sensors, other types along this particular stretch of freeway. And the little dots here are showing you where there are sensors along the whole freeway. And that's what the IPEM system does. it goes in and it takes an agency's existing data feed, whether that is sensors or data from people like here or INRIX, and it fuses it all together and presents it in this rationalized analytics system so you can visualize what's happening on the system. And this applies to any type of sensor. So in terms of what we have hooked into for agencies before, it's pretty much any type of traffic sensor that you can name, Wavetronics, EIS, radar, any type of loop, any type of sensor you can name, essentially, we've hooked into it for an agency and turned it into useful analytics data with IPEMS.
Back to MAP-21, how will requirements fall on MPOs and states differently?
That's a great question, and I really wish I knew the answer to the question. At this point, we can only speculate, based on what I know, at least, which is that, in the language in MAP-21, it's really oriented at states. Our best sense of what the rulemaking is going to look like is it's going to be a mix of requirements on MPOs and states, and we suspect that MPOs are going to be mostly responsible for, kind of their urban area calculations. That'll probably flow up to a state level. And so my best guess is that if you're an MPO now, you should be thinking about how do I calculate regional vehicle hours of delay, and how do I calculate travel time reliability for, say, the top 24 key routes in my urban area. But that's about all we know right now. We don't know the details of how it's going to divide out between states and MPOs. I think that's going to be something that's going to be key to be looking for in the notice of proposed rulemaking that's going to be out later. And one of the things I'd really just encourage MPOs to do, based on my discussions with clients, is just to pay attention to what's going on in terms of MAP-21, because we think there are going to be provisions for that MPOs are going to have to work on. Great question.
Okay, and I think our last one will be, does IPEMS include any information for arterials?
That's a great question. We actually have a separate product that is called, we call it arterial IPEMS. And this is a product that we sell to primarily cities and counties, kind of local agencies. This product is something that we're going to demo a little bit later on. Probably not for a few months, however. We built it originally for the city of Los Angeles. And what it really does is it does a lot of the same things you've seen here, but it really focuses on arterial issues. And so one of the big differences, for example, is that this arterial version of IPEMS takes in signal data at a very granular level and looks at progression quality and timings and helps agencies understand how to retime their signals more effectively. And so that's something you can look for in an upcoming webinar. If you're interested in getting a demonstration of that in the meantime, feel free to get in touch with us, and we'd be happy to show you about it. I will say that our new speed data connector, as you can see here, is actually pulling in data from arterials and doing some congestion metrics with the arterials as well. And so even in our kind of larger freeway product, we're starting to pull in some arterial data. You can see that here in the dashboard. We do have a more focused product on arterials for local agencies, however. Great question.
All right, everybody. I think that just about concludes our webinar for today. For those of you who'd like to follow up on this webinar or get more information about IPEMS or anything else we talked about today, we will be sending out an email shortly with Rob's contact information, as well as the link to the webinar on the Iteris website, www.iteris.com. Once again, on behalf of Iteris, thank you all for joining us for today's webinar on MAP-21 and performance measures, and we look forward to talking to you all again soon.
Thanks, Cindy. Thanks, everybody.